Hello and welcome to our BankSafe demo, a short video that shows how fake apps can get you in trouble and how you can use Approov to get out of this trouble again. In our demo, we are going to use a fictional fintech called BankSafe. BankSafe has produced a mobile application allowing users to log in and make payments from their personal bank accounts to other bank accounts. The app talks to BankSafe's server, which in turn uses an open banking API to initiate money transfers. We use the Open Bank project's API sandbox for this demo. Here we can see the app running in an emulator. For the purpose of the demo, we also run BankSafe server and the Open Banking API that it connects to locally on the same computer. In the BankSafe app, we can easily make a transfer to someone else's account like this. We are already signed into BankSafe and authenticated with the bank. We just need to go into payments. Everything is pre-filled for the demo. At the top is our account number, the recipient of the payment is Jack Wilson, and these are his bank and account numbers. We can then perform our test payment. After a little while, we get confirmation that the payment has been made successfully. And that's it. So far, so good. But a hacker has reverse engineered the BankSafe app and created a lookalike fake BankSafe app. They have bumped up its popularity by generating many favorable fake reviews. The fake app works exactly like the original, but is able to change the destination bank and account for payments internally without this being reflected on the display, and to divert the payment into the hacker's bank account. The hacker triggers this behavior at the time of the choosing and hopes that the many payments to their account will accumulate to a large sum before the attack is noticed and the service is shut down. The fake app is running in this emulator here. Before we see what happens when we use the fake app to make a money transfer, let's have a look at some account balances before the transaction using a very simple tool created for this demo. The tool talks directly to the Open Banking API. First, we want to look at the sender's account balance, the recipients, and the hackers. If you make a payment through the fake app, everything looks normal. The payment is successful. The confirmation states that the money has been credited to Mr. Wilson's account, and everything appears to be fine. But if we look at the account balances, the sender's account balance has gone down by $100. Jack Wilson's bank account still has the same balance. So that's not where the money went. But instead, the money was paid into the hacker's account, which now has $100 more in it. In this situation, a second authentication factor does not help, as it is the genuine user who is using the app. A payment confirmation page served by the user's bank and displayed in the app might help here if it shows not just the amount, but also the true recipient's bank and account numbers. But an inattentive user may still wave it through. What BankSafe needs is a way to determine what, as in which app, connects to the servers, not just who, as in which customer. Approov app authentication provides a straightforward solution to this problem. Approov periodically takes a non-replayable measurement of the app and its environment and transmits the result to the Approov cloud service in an attestation request. The service determines if the request is coming from an unmodified, authorized app running in an untampered environment. If so, the Approov service issues a valid, time-limited Approov token to the app for inclusion in any API request the app makes. If not, the Approov service issues an invalid token. The API server can then verify the Approov token from the request and permit the request only if the token is valid. After subscribing to an Approov trial and installing the Approov command line tool, BankSafe is ready to proceed with the integration of Approov into their app and their server. For the app integration, BankSafe follows one of Approov's quick start guides at github.com/approov. Since the app is written using React Native, the React Native Quick Start is the appropriate one. This quick start is particularly simple because there is an integration script available. Let's just run this in our BankSafe App project directory. Just use the default values here. And that's Approov installed in the app. Then we build and install the Approov protected app as normal. This will take just a few moments. The app looks and works the same as before, except that behind the scenes the Approov SDK requests an Approov token from the Approov service and presents the token as a header in any request it makes to the BankSafe server. There are two more things to set up before the app is ready to be used with Approov. Firstly, we need to register the app with the Approov service. The integration provides a convenient command for this. This makes the app known to the Approov service as a valid app from the original creator, BankSafe in this case. And secondly, we need to add the protected API to the Approov service. This tells the Approov SDK for which domains to request tokens from Approov and include them with every request. This is the command to add the API domain. Because everything is running locally in this demo, we have to use the local IP address as seen from the emulator. Approov supports pinning of the HTTPS connection between the app and the BankSafe server, and this would normally be enabled to prevent anyone from observing the traffic. For the demo, we have to disable pinning, as all traffic is sent as unencrypted HTTP. Success! That's the app done. To ensure that only the genuine BankSafe app can make successful requests to the BankSafe server, we need to add a validity check for the Approov tokens sent by the app. The server is written in JavaScript using Node Express. Approov provides a quick start guide for this too. The integration is quite simple. For the most part, we need to import the snippet of code which contains the Approov token verification function. Approov tokens are JWTs, JSON Web Tokens, and packages to verify those are available for JavaScript and many other computing languages. Since we are verifying JSON Web Tokens, we require the appropriate package here. This is the part that contains the Approov token verification function. And finally, we need to put a call to the verification function into the server. We do this here using a filter. To check the validity of the Approov token, we also need to specify the correct token secret to use. This secret must be protected and should only be known to the Approov service and the BankSafe server. We retrieved this from Approov using the CLI. This is the base64 encoded secret. Just for the demo, we copy the secret into the source file. Normally, you would retrieve this from a file or the environment. All that is left is to restart the server. There we are. The BankSafe server is running and checking Approov tokens sent by the app. Let's try this out and see what happens when we run the new BankSafe app. If you run the Approov protected app and make another transfer, we can see an Approov token check being performed by the BankSafe server for every request. As the token checks are successful, our payment also succeeds. And what happens if we run the Hackers app again? The money transfer fails. This is because the Approov token verification in the BankSafe server failed. A valid Approov token can only be acquired by the original registered BankSafe app. If the token is missing or generated in a different way, it will fail the server's token check, indicated by the Approov token invalid log message. The hacker's fake app is now locked out, and BankSafe's customers' funds are safe again. BankSafe is back online. To learn more or to sign up for a free trial, please go to approov.io or to approov.io/signup. Thank you for watching.